So this would be the beginning of our journey on vector algebra. Some basic foundation on vectors just come to you. I hope all of you understood everything that I have said so far on vectors, right? No confusion prevails, right? Now, A plus B, I know what to do. A plus B, the vector A plus B, that is the resultant of A and B, which is the resultant of A and B, I said is the following. If this is a vector A and this is a vector B, then this vector is going to be A plus B. This vector is going to be A plus B, right? That is the resultant of the vector A and the resultant of the vector B. However, if I said A minus B, then what this really means is that it's a resultant of A and the vector minus B. The resultant of A and the vector minus B. So if A was like this, B was like this, right? If this was A and this was B, then if B is like this, then minus B would be like this. That means this is A, and if that was B, then minus B would be like this. Minus B would be like this, clear? Now the resultant of this vector and this vector would be this diagonal of the parallelogram. So this will be the resultant of A and minus B. This will be the resultant of A and minus B from parallelogram law of vectors, right? So this vector is A minus B, A plus minus B, which is A minus B. The vector A minus B. So that's how you find the difference of two vectors. Difference is the same as, again, a summation addition only with a slight revision. So this is how you find difference of A and B. Now, the other way you could look at it is the following. No confusion, right? You're fine with these ideas so far? If this is the vector A and if this was B, right, then I could have also looked upon minus B as this vector. I could have looked upon minus B as this vector. If this was B, then instead of putting the arrowhead here, you put the arrowhead here, then this would become the vector minus B. Are you okay with this? This would become the vector minus B, right? And now, two sides of a triangle taken in order, isn't it? This is one side of a triangle, this is another side of a triangle taken in order. Then the third side of the triangle taken in an opposite order, third side of a triangle taken in an opposite order, third side of the triangle taken in an opposite order would give you the resultant of A and minus B, will give you the resultant of A and minus B. So resultant of A and minus B would be A minus B like this. Right? Now, look, one thing that we easily understood here was that this was the vector A plus B. This diagonal was the vector A plus B. This was A, this was B, this was A plus B, right? This was the vector A plus B, right? Now, if this is B, then as you saw here, this would be minus B, this would be minus B, yes or no? This would be minus B, then minus B plus A, I can add minus B plus A, I can add using triangle law of vectors. Minus B plus A minus b plus a would be the third side of the triangle taken in the opposite order. So minus b plus a would be the third side of the triangle taken in an opposite order. So will I not say that this vector must be a minus b? See this side? If this is b, then this would have been minus b. This would have been minus b, and minus b plus a is minus b plus a, which is using triangle law of vectors a minus b. Are you all okay and comfortable with this? Right? Now, which means in the same parallelogram in which this is the vector a, this is the vector b, this is the vector a, this is the vector b, this diagonal represents a plus b, whereas this diagonal represents a minus b, right? This diagonal represents a plus b, this diagonal represents a minus b. So this is important. One diagonal will represent a plus b, the other diagonal will represent a minus b. Now, this was a, this was b, and they enclosed an angle theta. Then this length would be mod a plus b, this length would be mod a plus b, is it okay? This length would be mod a plus b, and like I have already told you, mod a plus b whole squared, that means this vector is a plus b, and mod of this vector squared would be mod a squared plus mod b squared plus twice mod a mod b cos theta. Right? And if this vector is a, and if that was b, this was originally b, this was originally b, including an angle theta, then this would be minus b, this would be minus b, yes or no? And this would be the vector minus b, clear? This would be the vector a minus b, which is the resultant of a and minus b, which is the resultant of a and minus b, which is the resultant of a and minus b. Now, if I have to find the resultant of a and minus b, resultant of a and minus b would be a plus minus b. That's a resultant of a and minus b. Yes or no? Resultant of a and minus b would be looked upon as a plus minus b. If I have to find the magnitude of this, if I have to find the magnitude of the resultant of a and minus b, that again from parallelogram law would be mod a squared plus mod of minus b squared plus twice mod a into mod of minus b into cosine of the angle between a and minus b. Angle between a and minus b, which is 180 minus theta, yes or no? This is resultant of a and minus b squared, right? That's going to be, that is this mod of a minus b squared, that is this length squared, is going to be mod a squared plus mod of minus b squared plus twice mod a into mod of minus b into cosine of the angle between a and minus b. Angle between a and minus b is 180 minus theta. Hey, but mod b and mod minus b will have the same magnitude. B and minus b have the same magnitude, they are oppositely directed. So mod b and mod minus b are the same. So I can forget this minus sign, right? So, because mod B and mod minus B are the same. B and minus B are the same magnitude. So then this would become like a mod A squared plus mod B squared, and then cos 180 minus theta is minus cos theta. Cos 180 minus, by this time I had asked you to see that in bit of trigonometry, right? I expected you to know cos 180 minus theta is minus cos theta, clear? This is square of one of the diagonals, isn't it? This length is mod of A plus B, so this is square of the length of one of the diagonals of the parallelogram. This is the square of the length of the other diagonal of the parallelogram, and mod A and mod B are the sides of the parallelogram. Mod A and mod B are the sides of the parallelogram. Then cos 180 minus theta is minus cos theta. Cos 180 minus theta is minus cos theta, right? Now, if I add the squares of the two diagonals of a parallelogram, if I add the squares of these two diagonals of the parallelogram, see, one diagonal is mod A plus B of length mod A plus B, the other diagonal is of length mod A minus B. So, if I add these two diagonals, squares of these two diagonals, then realize that this would dispense away this. I have mod A squared plus mod A squared, 2 mod A squared, mod B squared plus mod B squared, 2 mod B squared. Is that okay? So then, this is simply going to become twice mod A squared plus mod B squared. You know what I am saying? This is square of one of the diagonals. Mod of A plus B is the length of one of the diagonals. So this is the square of one of the diagonals. Mod A minus B is the length of the other diagonal. So this is the square of the other diagonal. Mod A squared is this length squared. Mod B squared is this length. Right? I'm not sure if you had known this property in geometry. In a parallelogram, some of the squares of the diagonals will be some of the squares of all the four sides of the parallelogram. This is what it means. See, this square plus this square, we have got 2 mod A squared. 2 mod A squared, right? That means this square plus this squared plus 2 mod B squared, which is this square plus this square. Do you realize this statement? Sum of the squares of the two diagonals of any parallelogram. This is the sum of the squares of the diagonals of any parallelogram. That's going to be mod A squared plus mod A squared, which is this square plus this square, right? 2 mod A squared is mod A squared plus mod A squared, which is this square plus this square, and 2 mod B squared is this square plus this square. You know what I'm saying? So sum of the squares of the diagonals of any parallelogram would be the sum of the squares of the four sides of the parallelogram. Four sides of the parallelogram. Questions? This is a property that is very commonly used. Down the line in vector algebra, you might want to remember mod of A plus B whole squared plus mod of A minus B whole squared is twice mod A squared plus mod B squared, etc. Clear? Okay, for the beginner level vectors, we will continue with more on top of this in the next class on vectors. But I hope all of you are fine with these ideas. Should only have been a repetition of whatever you have seen. But if you have questions that you want to hurl upon me, feel free to do so. Feel free to do so. If there are things that you have seen and they've squeezed the hell out of you, I'm here to address all of them. But of course, I'm going to continue with other operations in vectors. Want to give you different geometric interpretations of various things in vectors. Would accelerate a little bit on vectors when I meet you next. But my class on Sunday is going to be a class on calculus. Your first stint with calculus. And if you don't remember your trig results, then you would be in dire straits. You must remember your trig results. That's a prerequisite to be able to comprehend those classes. Make sure, without fail, that you remember. Besides the fact that, the nursery rhyme sessions would offer that extra bit of flavor and color to the entire milieu of the class. That's only one aspect. The other aspect is that, you feel lost in the class on calculus if you don't recall your results. So, in the best interest of all, you and me, you remember your results on trig, right?